Hi everyone. In this video we're going to be working on 2014 AP Calculus AB free response question number 3. Now in this section we're not able to use calculators, so if you happen to have one, just put it away because all of this is going to be without using a calculator. Now going through this problem, you're going to notice two things. You're going to notice a graph, and you're going to also notice sometimes that your equation has a random equation that's in there, and that's fine. But when you have a graph, anytime you have a graph where it's like made up of geometric shapes, chances are they're going to ask you to find the area and also ask you to find the derivative of this. Okay, so you got to be careful. Now, going through this question, it says the function f is defined on the closed interval from -5 to 4. The graph of f consists of 3 line segments and is shown in the figure above. Let g be defined by the function g of x is equal to x to the integral of -3 to x of f of t. Meaning g of x is equal to the area, because remember, integral always means area, of this equation, which pretty much is you're finding the area of everything in between the graph and the x-axis. So let's go ahead and find part A. Well, part A is telling us find g of 3. Well, one thing that I remember is if we ever have g of anything or f of anything, we always take this number and plug it into the equation that stands for g, which is this equation. So then we're going to take that 3 and we're going to plug it in. When we have that, that just means that they're asking us to find the area from -3 to 3 of f of t. So that means that we're starting from -3 all the way to this number right here. So they want us to find the area of this triangle, but then also the shape that creates here of this triangle. Now the only thing is, I know what the base and height is for this triangle. I know what the base is here, but I don't know how far this goes down. I could assume it goes down to -2, but I can't be sure. I have to be careful. So what I have to do is, okay, since this is a line, I know that the slope of this line is down 4 over 2, which is the same thing as saying -2 over 1. So then I know that I can go down 2 over 1, and that's exactly where it's at -2. And you just want to check just to be careful. So now when I want to find the area, I'm going to separate the area by these two triangles, find the area of this triangle, which is equal to 1/2 times the base of this, which is 5, times the height, which is 4. And this is going to give you a total of 10. Then you have to find the area of this triangle, which is 1/2 times the base, which is 1, times the height, which is 2. And this equals to 1. Now there's one thing you have to be careful about when you're finding area that's above the x-axis, that's also below the x-axis. Area above the x-axis is always positive, every single time. Think of it as positive height. But whenever you have a triangle or a shape that's below the x-axis and you're finding area, it is always negative every single time. So then because of that, to find my total area, I have to find the number 10, because that's the area of this, but subtract it from the area that's underneath the curve, and that's going to give you a total of 9. And that means that this is your area. G of 3 from -3 to 3 is 9. Okay? So that's going to lead us to part B. Well, in part B, the question says, on what open intervals contained in -5 to 4 is the graph of G both increasing and concave down? Well, this is the part where look for our key words. Increasing, concave down. Well, we know it's increasing when you have to apply a derivative, right? Because whenever you do y prime, or in this case g prime, it's always derivative. And then concave down would mean concavity, which is only found by applying the second derivative of g, which would be g double prime. So once you know that, then you go ahead and actually set it up. I know g of x is equal to the integral from -3 to x of f of t. Well, what's g prime equal to? Technically that would cancel out this integral, because doesn't the derivative of an integral cancel out? It does. So g prime of x is just equal to f of t. What that means is this equation right here is the derivative of g of x, which is good because that means that any number that crosses through the x-intercept is a critical number of the original function. So what I'm going to do is, since I know this, I'm going to put a number line. I'm going to keep my bounds from -5 all the way to 4, because that's what they're asking us for, from -5 to 4. Then the next thing is find your critical numbers. Because this is your derivative, anywhere that it crosses the x-axis is a critical number. So from -5 to -3 all the way to 0. then my next thing is to go, I'm going to separate it. Now what's happening, since this is derivative, what happens when it's above the x-axis? What happens when it's below the x-axis? Well, the same thing as area. Anything above the x-axis of a derivative is always increasing. Anything below the x-axis is always decreasing. So from -5 to -3 is increasing, -3 to 0 also increasing above, and then 0 to 4, which that shouldn't be 0, sorry, this is actually 2, because you see how we intersect at 2. This is going to be decreasing. Now once you have that, remember, the reason why -5, -3, 2, and 4 are my critical numbers, -5 and 4 are my end bounds, where I'm going to, and -3 is my first critical number, and 2 is my second critical number. Those are the values that makes it equal to 0. So then I can say that it's increasing from -5 to -3, comma, -3 to 2, and it's also decreasing from 2 to 4. So then once you have that, you move on. You go, okay, well I have to find concavity, which is g double prime of x. That means that they want me to find my derivative of this equation. Because if this is g prime, this is g double prime, this is f of prime, this is f of x, this is going to be f prime. So they want me to find my derivative of this, and this is where you go, well how do I find derivative of a function? Well remember, derivative is looking at increasing, decreasing. So you can say that this is decreasing, this is increasing, decreasing. But how do I actually find my values? How do I know where it's increasing to and where it's decreasing to? Well, that's called a max and a min. So anywhere you have a max and a min of your graph, that helps you to find your critical numbers of your derivative. So when you set this number line up, you start off at your left bound and you start off at your right bound, and ask yourself, since I'm applying a derivative, where are my critical numbers? There's one critical number at -3 and another critical number at 0, a min and a max, and nowhere else. So then I can put -3 and 0, separate everything, and ask yourself, since I'm applying a derivative test to f, anything that's decreasing is going down, anything that's increasing is going up, anything that's decreasing is going down, all the way to 4. So then I can say concave up, because second derivative, from -3 to 0, and concave down from -5 to -3, but also 0 to 4. So once you have these values, you go, okay, well, what was the question asking me? The question was asking me, when is it concave down and increasing? So I don't really care about this concave up anymore. And I also don't really care about when it's decreasing. So once you have these values, you have to compare them, because not everything is going to be both. Well, let's look at when it's increasing, -5 to -3. Is it concave down as well? It is. So then this part works out. This interval, -5 to -3. Then the next thing you have to ask yourself, okay, well, it's increasing from -3 to 2, but then it's concave down from 0 to 4. What are the points that they have in common? Hopefully you only agree that the first one was -5 to -3, but then also from 0 to 2. That's the second point where it's concave down, 0 to 2, but also increasing 0 to 2. This is why this is my answer for part B. And the explanation behind it is just saying that the graph of G is increasing and concave down from these intervals. Okay? And then this is your work. So moving on to part C. Part C says the function h is defined by h of x equals to g of x over f of x. Over 5x. Find h prime of 3. Keyword, they want you to find this derivative. They want you to find this derivative. So what that means is you're going to have to actually find the derivative of h of x. Now you can't let it confuse you. When you see this, don't freak out. All it is, okay, I have a function, the derivative of this g of x is just g prime. I have 5x, which is just another function, the derivative of 5x is 5. So when they ask me to find derivative of something being divided, that's just a quotient rule. And that's where, the whole low d high minus high d low comes from. You take your low, h prime of x, so this is c, take your low, 5x, derivative of the high, which hopefully you guys agree would be g prime, minus your high, which is g low, times the derivative of the low, which is just 5, all over your low, which is 5x, and then squared. Well, then when you have that, you just have to work it out. Well, what value are we trying to find? We're trying to find h prime of 3. So let's just go ahead and plug that in. 5 times 3 of g prime of 3 minus g of 3 times 5 all over 5 times 3 squared. Now when you work this out, you know that 5 and 3 is going to give you 15. But the question is, what is g prime of 3 going to give you? Well, you have to remember this. Okay, so g prime of 3. Well, how do you find g prime again? If we go back, g of x is equal to the integral of f of x, or sorry, f of t. G prime of x is just equal to f of t. So then when you plug it in, that was this equation right here. So when they ask you to find g prime of 3, all they want you to do is find the coordinate of g prime of 3 here, which is 1, 2, 3, go down 2. This is the coordinate right here, 3 comma negative 2. So right next to here, you're going to put negative 2 minus g of 3. Well, did they ask you to already find g of 3? We did. They actually asked us to find g of 3 in the beginning. G of 3 here is the integral from negative 3 to 3 that we found in part A. And we said the integral for part A was 9. So you're going to put a 9 here times 5 all over 5 times 3 squared, which we'll just leave it as 15 squared. And then when you work everything out, you're going to get this, negative 75 all over 225, which simplifies to negative 1 over 3. Okay? So going through this again, if you ever have an equation where it's h of x is equal to a quotient rule, or something being divided, you have to apply a quotient rule. Low derivative of the high minus high derivative of the low all over low squared. And then just plug in the value that they're looking for, h prime of 3. 5 times 3, g prime of 3, which was just plugging into here, minus g of 3, which we found in part A, times 5 over that. And then you simplify and you get that answer. So now, this will lead us to part D. Part D tells us the function p is defined by p of x is equal to f of parentheses x squared minus 2x. Find the slope of the line tangent. All about keywords. They ask you to find the slope and the line tangent. Remember, slope is derivative. If this is my equation p, they want me to find p prime. So what I'm going to do is I'm going to go ahead and find p prime. And I'm going to put it on here. Well, p of x is equal to this equation. It looks confusing, I know, but it's one of those where, okay, well, if p of x equals this, and this is the derivative, kind of like that one. Didn't you say the derivative of g was just g prime? Well, what's the derivative of f? F prime, and I got to leave the inside alone. I can't touch it until, if there is an inside, I have to chain rule it, which would be 2x minus 1. Well, when you have that equation, your next step is, okay, well, what were they asking me to find? They were asking me to find that x equals to negative 1, so that's pretty much the same thing as saying p prime of negative 1. And when you plug it in, that's going to give you f prime negative 1 squared minus 1, minus negative 1, sorry, times 2 times negative 1 minus 1. And then you work everything out, work this out, and this is going to give you f prime of negative 1 squared plus 1, which would be 2, times 2 times negative 1 minus 1, negative 3. Well, I know negative 3 is negative 3, but what about f prime of 2? Well, f prime of 2 is the derivative at 2. The derivative of 2, which is the slope of 2. So then you got to come back over here. You got to ask yourself, well, what is the slope that's right here? So this is a line that has the same slope throughout the entire thing. Didn't we already say the slope was negative 2? Because you go down 4 over 2, down 4 over 2 to get to all the points. So because of that, the derivative of f prime of 2 is just saying negative 2 times negative 3, which is equal to 6. And that is your answer for part D. Does it look confusing because of that function? Yes. But find the derivative of f, which is f prime, because there's something inside, chain rule it. Then plug everything in and look at this table, look at this graph to help you find the values for it. Because you're asking for f prime of 2, this is f. F prime is the derivative of the slope. The slope of at 2 is linear, so they all have the same slope. Alright? So, going through the question, anytime that you ever have an integral, anytime you have a chart, they're going to ask you to find the integral by finding the area of above and below. They're going to ask you to find the derivative of this. Okay, derivatives occur at max and mins. Alright, hope to help. Thanks for watching.